In today's lessons, we're going to talk about the connectives. First, let's define what is connectives. Connectives is a function or a symbol representing a function which corresponds to English conjunction, such as and, or, not, etc., that takes one or more truth values as input and returns a single truth value as output. In propositional logic, it is generally used five connectives which are disjunction, conjunction, negation, implication, and biconditional. Let's talk about the connectives one by one. The first one is the OR connectives. The OR is operation of two propositions. A and B is true if at least any of the propositional variable A and B are true. Always remember the OR connectives is at least any, at least, the word at least, any of propositional variable A and B are true. Let's see the example table of connectives, the OR connectives. We have A and B proposition. Under the A proposition, its propositional value is true, true, false, false, while under the B is true, false, true, false. Then as we can see, the propositional value of both proposition when we use OR connectives are, if A and B are true, the propositional value is true. And if A and B are true, false, the propositional value is true. And if A and B are false, true, the value is true. And if false, false, the propositional value is false. And that's how the OR connectives works, or the example table of OR connectives. Then let's proceed to AND connectives. AND is operation of two proposition A and B is true if both propositional variable A and B are true. Remember from OR, uh, if any of propositional, it says an or one, but here in N connectives, if both propositional variable A and B are true. Let's see the example table of the N connectives. As we can see, propositional value of A and B, proposition, the value is still the same, but when we use N connectives, here's the signs or how you sign or mathematical signs of OR connectives. If A and B are true, A and B are true. If A and B are true false, the value is false. If A, B are false true, the value is false. If A, B are false false, the value is false. And that's how the N connectives work. As you can see, if A and B is true if both propositional variable A and B are true. Here, as you can see, the A and B have a similar true and true, which it became true in propositional value and connectives. And the rest is false, false, false because it doesn't meet the N connectives operations. Let's proceed to the negation. The negation of proposition A written as not A, or this is the sign of not negation, here as you can see, is false when A is true and is true when A is false. So let's see the example of the negation connectives. Here is sample table. As you can see, there are propositions A where the truth value or the value of the proposition A is true, false. As we can remember, is here the negation is false when A is true and is true when A is false. As you can see, if A is true, then it negates into false. when A is false, it's going to negate into true, or it's just like, in other terms, it negates the value of the proposition into its opposite value. Then let's proceed to implication. Implication A, here's the sign or mathematical sign of A implication. Implication A and B is the proposition if A then B. It is false if A is true and B is false, then the rest case are true. Let's see the sample table of the implication connectives. If proposition A and B are true, its implications are true. If A and B are true, false, the implication is false. If A and B are false, true, the implication is true. If A and B are false, false, the implication is true. If you're going to read this sign, you can read this as true, true. A, if A, then B is true. And that's how you read the implication signs or the mathematical signs. And let's proceed to the biconditional or the if and only if, where A, here's the sign or mathematical sign of the if and only if, where A, if and only if B is biconditional logical connective, which is true when A and B are same, then if both are not the same, it is false proposition. Let's see here. As you can see, remember this, both are not the same. Then both are not the same, going to be false proposition. But if the same is going to be a true proposition. Let's see is if A and B are true, true. A, if A only if B is true. Then another thing is the true, false is false. The biconditional proposition of the true, false is false. Then next is false, true, the value is false. Then false, false, the value is true. As you can see here, in the biconditional connective, which is true when A and B are same. Here, A and B are same true, which leads to true value of proposition. While here it is true, false, and it leads to false proposition, and the rest it's the same cases. Then let's see some example of the connectives, or let's see some problems. Here we have the A or B. Then the implication A or B. Here we have a value of true under the A and B, true, true, false, false, true, false, true, false. As you can see a while ago from the last is the previous slides, the value of A and B are fixed. So let's see the or here. Let's compute or let's try to solve this problem. As you can see, the OR connectives are being used in the application. First, let's try to solve the left sides where the A or B. Here, if as you can remember, if true, true, the value of proposition is true. And if true, false, the value is true. Then false, true, the value is true. False, false, the value is false. So you can remember, at least in OR connectives, at least any of the propositional value have true value, which this is 1. It's the same with here. Let's compute this, or let's solve this another, the right side. The A or B again. Let's just copy because it's the same with the another other left side. Let's proceed here. We use implication here, or the implication are being used here. As you can remember in implication, it says that if the value is if the value is if the value is a if the value of A and B, it is false if A is true and B is false. Here, let's say the value of A, this one is true, then the propositional value is true. While this one is the propositional value is true, then it's going to be true. True, true is going to be true. False, false is going to be true. As you can see here. From the previous slides, I've shown you the example table of the each connectives, and then let's proceed to another example. Here is the implication, or the not, or the negation, I rather say, the negation of A and B. Let's see, let's try to solve this. Here is the truth value of the A and B, which is true, false, false. True, false, true, false. Then let's try to compute first the end connectives, or the A and B, which in here, if you're going to true, it will going to be true. Then true, false, they're going to false. As you can remember, the OR connectives operation, if A and B is both true, the propositional value of A and B is going to be false. Then here you can see if both true, they're going to be true. Then the rest is going to be false. If true, false, it will going to be false. False, true, it will going to false. False, false, it will let being false. Then let's proceed to the negation part, or the value of the negation, the proposition, or the connectives negations. Here, it will go, as you can remember, uh, is if A is false when A is true, and it is true when A is false. Here you can see if it's true, the value is false, and if false, the value is true. If false, the value is true. If false, the value is true. And that's how the proposition, or the negation works. And that's all for the lesson. Hope you learn about the connectives. Thank you.